everyone is joining us. We already have 20 of you, so I will be admitting as everyone comes and joins us, but I think we can start. And today we have Julian joining us. Julian, hi. So you are in London.
Yeah.
But with a beautiful, beautiful backdrop. Looks like you're somewhere on the beach, which is amazing. Yes, we all want to be somewhere like that. So welcome and thank you so much for joining us. So it's fantastic to have you talk to us. I think you will be the first speaker covering NLP, so which is brilliant. So it's something you're going to introduce. Our very first talk yesterday was about ethics. And I think we all agreed during this talk and after this talk that it very much depends on the individual responsibility as well. Whenever we develop the code, and the onus is on us, and very much depends on sometimes even personal values and whatnot. So, but the responsibility is with the people who develop the technology. So Julian, whenever you're ready, we've got 25 people for now, and everyone will be joining in as well.
Great, that's fantastic.
Well,
thank you. I'd like to share my screen, but I don't think I have privileges because I'm going to be showing some slides.
Okay, so let me give you those privileges to share your screen. And I assumed everyone can actually, but let me see. I am going to make you a co-host, and that should resolve that faster. And one participant. Okay, let me show.
Oh, I see. Whoops, sorry. Now I'm an admin. I can admit people in the waiting room. Apologies. I let someone in. No, I didn't know what it was.
I will be doing the admin. Don't worry about it. You just focus on your presentation, and you should have the screen sharing option now.
It looks like I have to quit and restart Zoom with these new privileges. So let me just do that for us right now.
Apologies for that. Welcome everyone. We are about to start as Julian is
sitting on my screen share.
Is it better now? Fantastic.
Yeah, it's good. I'm just there we go. I see it was hidden away, and now I'm going to let's go here.
Okay. So
welcome. Radio. Now I'm just going to share my screen.
Perfect.
I see what's going on. It's over here, and then just one. Okay. That's the one. This one. Okay. Right. Now the volume will see. I'm not sure how that's coming through, but I'll try and make that audible for people. Okay.
Welcome to Teens in AI.
There's control panels sitting on top of my controls. Let me just go back here. There we go.
Welcome to Teens in AI. My name is Mia. I don't actually exist, but was created by my host, Julian Harris, as a demonstration of some of the amazing things happening in the natural language processing space. In a moment, I'll hand over to Julian, but first, I wanted to thank Synthesia, a London-based startup, for making it so easy to create me.
So that's hot off the press. Synthesia launched that avatar creation tool just a couple of weeks ago, and I know that team fairly well, so I got access to that this morning and built that up. It's incredibly simple to do. In a follow-up session, if there is such a session, we can talk a little bit about how that can be done, but it really is just type some text, choose a character, choose a background, boom. So this is a hint of the kind of thing that's happening and becoming mainstream now in the territory of synthetic media. So hello everyone, yes, my name's Julian Harris. I am a proud father of two. I've got a 9 and a 5-year-old, and I've had the great privilege of working in a lot of different places over the last 25 years or so. I was actually a teenager myself once, back in the 80s. So go Ready Player One. If you watch that movie, you'll see my a lot of my memorabilia in there, what I grew up with. And so I've had great privilege to work at companies like Google for about 8 years, in UK government, where I created the UK government's first Alexa skill back in 2016. I've also been working in AI companies where I've been building some expertise in deep learning, machine learning, natural language processing, that kind of thing. Then I've also, as I mentioned as a preamble to this session, a lot of exploration into climate change recently, and really thinking a lot in the last year or so about what I can do that's meaningful and making an impact, applying my skills into areas that matter, because none of this matters until we fix the planet. So if we don't fix the planet, we're not going to screen share. I might have that little thing there. I'm going to remove that out of the way. So we're entering a new era of computing, and all of you here are experiencing a very, very different landscape, technology landscape, to the ones that others before you have. You're the first ever humans to experience these new things as part of your day life. What I've done is broken it into 3 or 4 broad categories of change, things that you will have grown up with, things that are new to you too, and things that are yet to happen. But broadly, I sort of spread them out to this capacity of speaking naturally with computers, the ability to talk to Alexa or Siri or such like, and ask questions and understand, was science fiction for the previous entire human history. So the fact that you can do that is absolutely extraordinary and yet normal. Same thing with hand and face gestures, the ability to detect things as you move. Anyone here has got an Oculus Quest. It's pretty amazing. When you stick your hands out, you don't need controllers anymore for lots of games. It just recognizes your hands, and you can actually manipulate these things with these virtual hands. So the hand and face gestures is becoming part of this world as well. Then body gestures as well, and thoughts and feelings. Computers are increasingly able to, in certain contexts, detect and interpret certain responses in a way that it hopes is related to something that you feel. So that's the broad picture we have. I wanted to talk also briefly about the difference between traditional engineering and machine learning. Now, what are those differences? This is particularly valuable for those who've come up through the world of technology, understanding traditional programming, which is, for most of my audiences, everyone. For you, you're in an exceptionally lucky position where you'll see this mixture as normal as well. So traditional technology is really about if this, then that. So you tell a computer what to do with rules and facts. If it doesn't do that, then that's a bug. And so this is what engineers like to call this deterministic programming. I'm just going to double check because of the screen. Who here can't see my screen? Is anyone? Elena, is it looking okay? Because on the panel here, I don't see my presentation. I just see my face. So I just want to double check that yes, my presentation is up. Fantastic. I didn't want to go on and then people get confused about what I'm talking about. That's great. Yeah, so it's this idea of deterministic programming is you do something and the computer doesn't do what you told it to do, then that's a problem. And the reality is that our world is full of rules like that. You know, there are things that can't be violated. And so rules are actually pretty important. They're quite valuable. Then again, there's other sides too. And the machine learning AI space is what I call probabilistic technology. That is, it's to do with probabilities or likelihoods or chance. It's about guesses, predictions, examples, and patterns. So, for instance, a machine learning system which is a probabilistic technology, you give it, the computer, examples of what you want, and then you say what they are. So you say, here is a cat, and that's a dog, and you label it, this is a cat and this is a dog. So you actually just give it a little label, and you give it lots of those. And the magic that's been happening in the last, couple of 10 years or so is that computers have had the capacity, the resources and processing power to be able to do that with quite a lot of images. So the image recognition database that's built a collection of a large number of images has about 12 million images, and they've been labeled through a massive crowdsourcing effort that's been going on for many, many years. And what's also interesting is what happens when you give it a new image, right? What happens when you give it an image that's not seen before? If you create a system that can tell the difference between a cat and a dog from previous examples, then the system's trained on those things, and now it changes state into a new, much more efficient part of the system, the inferencing system, the prediction system. It's done the training, and now it's like, well, okay, give it a new image. Now, is that a cat or a dog? That new image might be a cat or might be a dog, and it will try and predict based on how many examples you gave it. What if you gave it a picture of a fish? What if you don't train it with any cats? So you label dolphins as cats. So you've got things labeled as cats, but they're not actually cats as we see them. But what happens also if you say you mislabel dogs as cats? So you label chihuahuas as cats or such like. So they're just some of the things that can happen that can introduce problems with the prediction. You're going to see this again and again in my talk, that the system is about, really it's about garbage in, garbage out. So you give it lots of examples and you give it the wrong data, or you label it incorrectly, you give it the wrong kind of information connected to it, then it will only work on that. So when you're building products, and I mostly think of myself as a product designer these days, the challenge is, how do you create a system that is reliable, that does what people expect, when you guarantee that the system will not have been able to have seen the information that the users give it. So for instance, that classic faux pas at Google where they trained a whole series of data so that it could recognize people's faces and objects in Google Photos. And then there was a furor around 2017 or so where it started labeling some images of African Americans as gorilla, right? So this was a good example of, they didn't expect that, and that it was also, how do you deal with it? And the reality is that that's business as usual, that the system you have is not going to be perfect when you launch it. That when you're designing a system to be used by other people, you have to have committed some capacity, some support for being able to fine-tune it once it's launched, so that when new pictures come, you go, well, that's wrong. So human oversight after a product's launched with machine learning is actually not only a good idea, but is actually critical. You will not get a good system unless you actually start learning from the real data as well, from the real world production data from customers. So a good example of this actually is, although this is a natural language processing talk, this is a really good example from the image space. So there is a really exciting Hollywood notion that you've probably seen in many movies, where you have a picture and the cops look at the picture and they say, enhance, 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 enhance. And so this blurry pixelated image suddenly just gets better magically, right? It's like, whoa, it's incredible. It just got this magic little clue. My favorite one is from Blade Runner, where it read the serial number from one of the fish scales that was in the mirror of a reflection of a doorknob and whatever, you know, it was like ridiculous. So there's actually a whole industry of research around that. It's called super resolution. And super resolution is about trying to guess what the pieces were in a degraded image. Now, all of you here, there's a really good chance that there's almost no one on this group that can't figure out what that image is on the top. And so what the particular system that this was demonstrating tried to reconstruct that image, and I'll show you what it produced. So that obviously isn't Obama, right? There's another characteristic here that's quite clear, but I'll underscore it with this next one. This was also trying to reconstruct a pixelated version of a giraffe, right? So that's the pixelated version of the giraffe. And what did it try and reconstruct? Well, it created Giraffe Boy. So the problem here with this data set is that it was essentially had a massive bias in its set towards white male faces. And that means that you're going to get white male faces, even if it's a giraffe. So Giraffe Boy is someone we'll see shortly, a little bit later too. We'll refer to him. And this is a brilliant example of business as usual. And hopefully the industry is learning more and more about asking that question, that, to be honest, anyone here who has an aspiration in user experience, it's a really basic question. From a user experience point of view, the question is simple. What's the context in which you're using your tool? The context is, for instance, if you're collecting pictures of people's faces from the general public, you need pictures of people from the general public. You can't then just grab a free database off the web that happens just to have psych interns from year 2, right, or whatever. I mean, you can't do that because that's not the right context of use. So the user experience crowd will look at it and go, well, it's really obvious and simple. You don't have representative context, and that's quite important. Even if the difference is the free set of data is getting you so far, but your specific set of data for your particular product is different, that does really translates to a difference in cost and time. Suddenly you go, well, we could use this data set, but we actually need to make some changes to it, or we need to augment it, or we need to do something else because our context of use is different. It might be different language, it might be different people, faces, it might be who knows what, but that's something that needs to be done. And for those who are curious about this, one of the tricks that can be done to improve this is a system called fine-tuning. So there's actually a way of being able to do small incremental changes on top of an existing set of data. So in theory, if you took this database and you added a whole lot of pictures of giraffes and a whole lot of pictures of non-white males, then in theory, it could, with only a small amount of effort, not a completely big piece of effort, you could actually, in theory, improve it. And that's one of the exciting things that's been happening in recent times, is that you can fine-tune these systems a little bit. So there's a lot of stuff going on in natural language processing. And in this very short period of time, I'm just going to go straight to the kind of shiny, exciting, toy, fun stuff, because the how part is much more dry and needs a lot more concerted effort. And given it's 5 p.m., everyone here is pretty tired and had a long day. It's probably quite hot too. I'm going to talk about one of the cool, sexy things that's come out in just the last month. So the buzzword of July 2020 is a cryptic phrase, GPT-3. Now, GPT-3 is the latest code name for a long chain of systems that basically are using massive amounts of text to try and create some general purpose understanding of how language works. Now, the way I present this is to describe this phrase. Yeah, sorry, I'm jumping around a bit. And what you're going to see, actually, when I saw this kind of stuff with GPT-3, there was definitely a quote that leapt to mind, which was Arthur C. Clarke. He said, any technology sufficiently advanced is indistinguishable from magic. And some of the stuff does really come across as magical. And it's one of the fun things about natural language processing is that it's producing systems that really often make you gasp. Like that first video of that woman, Mia, that was the first time I've been able to do that, and it was pretty amazing stuff. And yet we've got engineers in London doing that. So the idea for this GPT-3 system and all its predecessors, and this has been created from companies such as OpenAI and Google and Microsoft and a few other Chinese companies too. So the idea is learn from all the web. The idea is that if you look at the language used on the web and all of the other things that are used on the web, can you somehow create a system that can generate new text in some way? Can you get a system that can understand, quote unquote, understand the system, the world? Well, so given some text, and fundamentally what it means is you have what's called a prediction system. That's all it is. Given some text, what's the most likely next text? So GPT-3 is getting rather good at this. And this is the one that came out just a month ago, actually less than a month, about 2 or 3 weeks ago. There are some caveats too. So it's still just a prediction system, right? And it's based mostly on the English written word, because that's what the web is mostly. And the biggest problem with this kind of stuff, and as in terms of progress with AI, is that there is nothing like the volume of data that you have with English text that you need for spoken word and images and physical properties and all those other things. They just don't exist. And so while it's pretty exciting what's happening there, it is not a solution that really is useful or helpful in other areas. And so it doesn't really generalize in a useful way. It's not like we're going to get some way of being able to do that for other forms such as speech recognition. But anyways, that's it. A few demonstrations that I think are pretty fun. The first one I want to demonstrate is called Write with Transformer. So I'm doing screen sharing, so it should just pop up here. This one I'm going to do here. So this is a tool. I'm going to make the screen bigger so you don't just squint. Let's see if I can do that without causing problems. I say the Teens in AI program is a new, and press tab, initiative, type of AI for young professionals in Australia. What it's done is it's come up and looked at essentially all of the internet and predicted that this might be a useful phrase. It came up with some various suggestions. So you can go to transformer.huggingface.co and just have a play, and there's different versions of this. Other one could be, say, climate change is not what we need. Expected to have profound impact on the environment according to reporters, blah, blah, blah. So there's some suggestions here, and then you can just keep typing. You could write a story. So once upon a time, Prince saw a lovely tab, warm-looking man. Woman, girl with long hair, and a boy with long hair, and a beautiful girl with beautiful. So this is called Write with Transformer. It's a fun tool. It's a creative tool. Some people use it to help creativity. It's demonstrating the creative parts of AI these days. And those with really sharp eyes would have seen this as GPT-2. So in fact, yes, this is in fact 2019. That's very uncool and uninteresting now. So what's really exciting with GPT-3 is it's got a couple of really interesting tricks that it basically allow it to be even more intelligent, quote unquote. And I'll give you some examples. There's a whole lot of them. And as I say, this only came out 3 weeks ago, and I don't have access to the API that allows me to experiment with this. I'll show you a few examples of what's already out there. So one of them was that there are lots of different ways that natural language processing can be used. And these are called, in the jargon, in natural language processing, or NLP, tasks. So one of the tasks is translation. Another is summarization. Another is understanding the entities, like which one is the noun, what's the noun, what's the verb, what's the relationship between those things. There's about 20 or 30 tasks that are being each researched individually. And the exciting thing that happened with these general purpose models is that they seem to be producing better results with this one repository, this one resource for all of these tasks than individual optimized specialized research tools. So before these general purpose tools, there was a system that said, hey, I'm just going to do the best translation system ever. And they just focus all their effort on being really good at translation. And then best summarization ever, the best entity extraction of the items in the text. Like when you say the fish rode the bicycle, it would say the fish is the noun, and then it's the subject, and then bicycle is the object, and such like. So all of those things got thrown out the window a wee bit at the end of 2018 when the first of these general purpose language models came out, because these models were a basis upon which all of these different tasks actually got better. And they just did it by grabbing pretty much all of the internet text or something close to that and doing clever things. And one of the clever things GPT-3 did, one person did, was summarize an entire movie using emojis. So Back to the Future, Zootopia, The Hunger Games. So what is this showing? This was a really simple example of this system that all they did is they gave examples of the kinds of things they're trying to talk about as part of the system, and then it would actually produce these emojis, and it showed that it had some context. It's an interpretation of the common internet, what they call the common, I think the common text, I forget exactly the repository name. It had figured out that these emojis represented something that was somehow associated with that term, even though no one has ever done this. No one's ever created these emojis. It just came up with them. So that was kind of fun. These are really just toy examples, but they're pretty interesting and hopefully leave you with the idea and the inspiration of where we are and what's starting to become possible. So I'll summarize with an opportunity slide too. So what about common sense? Now, this has been a huge frontier of excitement or research for natural language processing. How does a system know things? And there's been lots of ideas, even the very smartest minds of the world have been really struggling with this. And GPT-3, this latest version from OpenAI, seems to have quite a lot of it. And when I say seems, again, this is a probabilistic technology. No one really knows how it figures it out, other than they know the components. But it is an emergent property. It is a property that's come out of it that no one really expected, except they hoped that it would do this. So, for instance, here are some really interesting questions. So one website, I've got links to this later, common sense questions, right? What is your favorite animal? The system replied, my favorite animal is a dog. Why? So all the A's is this GPT system responding. Because dogs are loyal and friendly. What are 2 reasons a dog might be in a bad mood? 2 reasons a dog might be in a bad mood is if it's hungry or if it's hot. How many eyes does a giraffe have? A giraffe has 2 eyes. How many legs does a frog have? A frog has 4 legs. Now, so far, this is pretty magical, right? Going back to Arthur C. Clarke's comment. This is like, what is going on? Literally, all it did was crawl a couple of petabytes of data, and it came up with this. So it literally just figured it out. It seems to be intelligent, right? And then it gets kind of fun. Remember Giraffe Boy? How many eyes does a giraffe have? A giraffe has 2 eyes. Well, how many eyes does my foot have? Your foot has 2 eyes. Okay. How many eyes does a spider have? A spider has 8 eyes. How many eyes does the sun have? The sun has 1 eye. How many eyes does a blade of grass have? A blade of grass has 1 eye. Right. Okay. So again, it's predicting. Now, it could say, I don't know, and that's one way of handling it. And that is also dealt with in some ways. Then it starts getting really psychedelic, creative. Now, those of you, I think probably just Elena, but you might know young kids, right? I mean, this is my youngest. I remember, like, when he would explain the world, he was very confident in his answers. And these sound a bit like the kinds of answers that my 5-year-old would have given when he was 3. How do you sporgle a morgle? You sporgle a morgle by using a sporgle. How many bonks are in a quoit? There were 3 bonks in a quoit. How many rainbows does it take to jump from Hawaii to 17? It takes 2 rainbows to jump from Hawaii to 17. Which color does green ideas sleep furiously? Ideas that are colored as green and sleep furiously are the ideas of sleep furiously. And this really reminds me of my son when he was younger. He would explain things recursively. I say, why did you pick up, why did you drop that glass? So I dropped the glass because I dropped the glass. At one point, the reasoning of younger kids was literally self-referential, and they were quite comfortable with that. So this is kind of really feels like a young kid. Do you understand these questions? I understand these questions. So this is a good example of, when it suddenly looks magically incredible, but then equally, intelligence is not a clear cut, like this is right and this is wrong. These are facts, and it's trying to do something. Now, digging under the covers a wee bit, one of the parameters, one of the options and settings you can choose with GPT-3, along with quite a lot of these systems, in terms of its prediction, is a slider that changes it from to be things where it's really certain of the really high confidence to much more kind of creative. It's called temperature. So when you play with these systems and you see anything called temperature, like you might have seen it in the Hugging Face one, 0 means I'm trying to stick to facts. It still won't get it right. It's going to predict. Facts meaning much closer to what's actually there, but the 1, you set it all the way to 1, and that's really going to be like really creative and start including all sorts of stuff that it doesn't really know about, but hey, why not? Give it a try. So when you're doing creative stuff, you'll change the temperature closer to 1 to get some really crazy stuff. So what about the climate then? I talked about the climate. The climate is the crisis we're in at the moment. No conversation about technology or anything else, but for that matter, should not include a conversation about how it relates to the climate. And in this case, I'm going to talk about the fact that technology in general is adding a lot of carbon. Data centers generate about the same amount of carbon as emissions as global airlines, which is around 2%. Okay, so that's the bad side. It is, a massive contributor. These systems are really big. I'm hopeful though. There's a couple of things. AI for good. There's a lot of companies trying to do this thing, using AI for more intelligent solutions, such as sequestration, which is a term I just learned myself too, which means the pulling of carbon from the air. So there's using AI in these spaces to be more intelligent about how we use resources and how we also reclaim and extract carbon and such like. So there's some quite good things there. And the natural market forces too is another force that I'm very hopeful about because of three things. When costs align with carbon emissions, that is, it's costing me more money, I want to save money, naturally, in many respects, that also reduces carbon emissions in many cases. Cloud competitors, everyone's trying to be more efficient because it costs more to emit more emissions. So the cloud competitors are all trying to get better. So they're all making their own chips because machine learning chips are much more efficient and faster. Also, programming languages, just a fun fact, writing in Python is 20 to 25 times less efficient than Go or Swift, one of the compiled languages. So when you're looking at greenness, these languages like Python, these interpreted ones, PHP and such like, these are in JavaScript, less so JavaScript for various reasons I can explain later. These are really, really big deals that can make a huge difference. And also machine learning model optimizations. The demonstration I showed with Hugging Face was, in fact, I showed one called Distill GPT-2, and this system was an optimization of a previous model that was something like twice as fast and used only 1/3 of the resources. And so there's lots of areas where natural market forces, where cost aligns with carbon emissions, are reducing the impact, and that's a really, really good thing to work with. There are other things you can do yourself as well, and there's increasingly resources that you can find to look at how green you can be. The Green Web Foundation is one great resource for learning about how your web pages can be greener for technology in general. Okay, so I'm going to touch briefly. This is the point where I can dip a little bit more about the future, but this is a nice break in case this is the cutoff point. So Elena, I'll just quickly defer to you, and if this is a stop point, then we can finish here. If not, I can ramble a wee bit about some of the future ideas.
No, I think I would love to know about the future, because that was going to be my question anyway. So I think you will be talking about something I was going to ask you about. So go ahead.
Yeah, brilliant. Okay, well, the statement that the future is here but not evenly distributed couldn't be more true now. So I'm sitting here and I have a fairly smart home. I've got a bunch of Alexa devices sitting around. I'm used to saying to Alexa, add peas to the shopping list when I've got my hands covered in avocado or something, right? I'm used to that, and it's an expectation. But there's a massive number of people who don't even really know what a voice assistant is. That said, in the UK, something like 1/4 of all households use a voice assistant at least once a day. So it's moving, but other countries don't have this. So there's definitely an uneven spread of this. And the future of this is a number of big things that I get really excited about. I'm going to touch on some of the really crazy technology that's happening that we're going to start seeing really starting to impact things in very positive ways. So the first is that we've got this world of digital beings. This is a baby X. Now, this baby is completely simulated. It's a virtual baby that's been created by a very smart Kiwi called Mark Sagar, and he created Soul Machines, and he's created these digital avatars. He pioneered this, and Baby X is a research baby that is completely digital. And here he is showing Baby X a picture of a sheep, and then associating that with the word sheep, and then with an apple, and the baby's using the computer's camera to associate those things together. And so this is kind of the kind of things that's happening with association learning, and it's starting to link these things together. And that's what they use for their research. And they've also got customer support avatars that have been used in a growing number of companies around the world with hyper-realistic imagery. Mark's background is actually he did all the technology for movies like Avatar. So really world-class animation technologist, and his animations are exceptional. So Baby X is extraordinary, and there's a couple of documentaries on that on YouTube you can watch. Then there's other things like the role of voice. So maybe you don't actually need to use your voice, or what happens if you don't have a voice? Alter Ego by MIT is pretty exciting, because then it covers this territory of having this essentially detecting the chemical and electrical signals that are going on inside your brain from a device that's lining your jaw. So it's not bone conduction audio. Turns out that when you're going to say something, there are signals that are reliable and detectable that can be picked up even if you don't actually say it. So if you think, or if you visualize saying the phrase, "What's the weather here?" So if I just think, so I thought, what's the weather here? Alter ego would actually detect that phrase from your brain, from the neural pathways, and from the signals that have gone through to, I don't know which part, but it's absolutely extraordinary. So one really exciting avenue here is actually where voice becomes optional, so you can actually communicate with thought. So thought computing. Another area that's quite interesting is just pure brain activity. So just capturing mind reading. Now, this was an experiment where this person collected the stuff by actually, they had an invasive brain procedure where they actually had an opportunity to access the brain for, it was a epilepsy operation. And so while they were there, they embedded some mesh to detect stuff, and they were able to read the mind directly in a much more direct way than alter ego was. And so this kind of stuff's happening in multiple fronts, and is really becoming increasingly likely that a future 10 years from now, we'll be able to communicate with thought, for sure. And then we've also got lip reading as well, which is great, again, for accessibility. So an ability to be able to pick up what is being said. So you saw the demo, the first thing shown today was Mia, where the lips were simulating the words based on what I typed. And this is the other way around, so picking up what was being said. Again, this is really great for a lot of situations, what we call accessible situations, or situations where accessibility is a consideration, and this affects everyone. You might be in a noisy factory, you might be on an airplane, you might be something, where you can't actually hear them, you can just see. So this is quite an interesting augmentation as well. Digital beings, as I touched on briefly before, is a framework that I put together in my research in the last couple of years. What I'm seeing happen in the space of digital beings is this ability for people, for the system to sort of evolve into three different kinds of roles. The first role is this role of a concierge. They work on your behalf with the outside world. So you can say, Alexa, please go and find out a good price for the tickets on this concert when they're available. And so it could sort of hang around and say, hey, by the way, this auction started on this other website and I've bid this price or whatever. The concierge is a delegation of tasks. Companions is what like to make you feel loved and happy. The digital companions like Xiaoice, used by 660 million users in Asia. I kid you not. That is absolutely true. So have a look for that word Xiaoice. There's not much in English, but there is a couple of things and it's unbelievable. China is way ahead in AI, actually, in many respects in NLP, and Xiaoice is extraordinary. And then coaches, digital coaches is a space where it's about a tool that helps you improve. They're committed to the outcome. They're committed to improving your experience of the world, but it's that you're not delegating. They're telling you to do stuff. So a good example of this is vTrainer, VITRAINER.com, vTrainer.com. It's a device that you run with, and it coaches you on better running practice. I tried it a wee bit, and it's pretty extraordinary how it helps me. I'm not really a runner, but I ran more than I ever have with vTrainer. So these areas of concierges and companions and coaches, as part of this broader digital beings framework, is moving us quite rapidly towards a future where we have this additional kind of these support entities in the world that help us augment our lives and make our lives easier. So wrapping up, these are things, I talked a lot, it's late, and you've all been, I'm sure, dying to do whatever you do when you're not sitting here listening to some old guy talking about NLP. If you do nothing else, please remember these things, like machine learning, garbage in, garbage out. So adding AI to things is just, it's fiction. It's usually going to fail if that's how you take the approach. It's a way of adding intelligence to a process. It's a way of adding predictions to a process, to something. But it is very much dependent on what you have to start with. And if you don't have something that represents the context in which you're going to use your system, then you are likely going to get all sorts of errors that that manifest themselves in different ways, such as bias. And some of that bias can be, can be pretty embarrassing and sometimes illegal. So synthetic media, such as Synthesia's demo of Mia in the beginning and Soul Machines, is here with us to stay. So this moves into like the world of fake news and things as well, which I'll touch on very briefly next. And also the other thing to bear in mind is that cloud is a really big contributor to carbon emissions. And there's a lot of great work around understanding how you can help machine learning to help combat climate change. So those are the key things. That's the slide I think is a good recap of what I covered without the fun, exciting pictures, but the most important messages. Career opportunities, I think there's 3 things that are really, really exciting. First of all, human language and technology. So linguistics and communication in general, this is an enormous opportunity, helping with conversation design, helping with understanding. These are whole new areas. And when I've seen this happen a few times in my career, where you have a new skill and the prerequisites for that skill are non-existent. So no one really has or reasonably expects there to be material behind that job, so that you can come in and you can get away with having many fewer qualifications than, say, you would in other areas, because the industry expectation is still quite low. I've seen that with lots of times in the past with user experience and many other areas where, the starting point, people were able to move from other areas quite quickly and harness that opportunity and really have very successful, profitable careers. The other one is facts and disinformation. I hear, yes, there was a conversation yesterday about ethics. This is very new. It's very new, yet it's a real crisis. It's already affected political and therefore governmental policy. And there's a lot of companies. One that I know in London that's leading this is a company called Fact Matter, and FACTMATA, and there are others too. There's one in the US called Marvelous.ai, and so there's a few of them around now. But this area of being able to provide a way of saying, do I trust this information, is a question that is increasingly critical in order for people to be able to even construct belief systems. And this is really, really exciting area that's going to just grow hugely, I think. And the final one is this area of what I've labeled gestural creativity tools. So this ability to use tools to give broad ideas and saying, I kind of want this thing, and then the system come up with a starting point at least that you can use to move forward quite quickly. I have an entire talk on this actually. If you look on YouTube, you'll see a video called Future of Creativity, and I showcasing a very talented woman named Christine McLevy-Payne, who's done some work in OpenAI on music. And so if you look at that YouTube video from CogX 2019, you'll see some incredible examples of where people start and they say, well, this is what I want broadly, and then it comes up with all the detail. And sometimes it's actually enough for what you want to do. So those are 3 really exciting career directions, and they're all quite new. And there's a huge opportunity, and the access to resources for you to pick them up now is like they're at your fingertips now. I mentioned a few resources here. Again, this is just more for reference. I talked about AI for Good. I haven't put any URLs in because you should be able to just type these things in directly into Google and you'll come up with the results. There's AI for Good, there's Fast.ai, and Coursera's Deep Learning. These are excellent courses. The Coursera one is great because you get a qualification at the end, and it's cost like, a really nominal sum each month. That's really great. Fast.ai is a course that you have to sign up for at San Francisco University, and that's much more expensive, like thousands of dollars. But the Coursera one is excellent. You do need a maths background though. It's machine learning is a lot about, for me, brushing the dust off some stuff that I was learning in secondary school, quarter century ago, around statistics and a bit of calculus and things like that. Not too much, but you need to be comfortable in that space, or at least have rediscovered the beauty of maths before you dig into this. Green Web Foundation I mentioned. Project Drawdown is really critical. It's an amazing repository of all the possible solutions that climate change could occur, where it can, and the potential impact of those things. Extraordinarily, some of the biggest impact is waste. So where waste is lost, and also educating girls in third world countries. Turns out that the projection on how that could improve the environment is extraordinary. So there's really interesting opportunities and how the climate could be improved to combat climate change so what I was saying is this Project Drawdown has a really great catalog of these things. And as you pick up skills in this territory of traditional technology and then machine learning, this is a palette upon which you can build new solutions that are become increasingly rich. And so that's why I spent a lot of time in the last few years going right back to my technical roots and understanding the space so that I could be armed as a designer, as a solution provider to come up with solutions that could use these tools. Because if you don't know what machine learning or deep learning really does and doesn't do, it's pretty hard to come up with solutions that apply it. And so that's something I really recommend, the Project Drawdown. Synthesia I mentioned, and there was this phrase, you search for data centers generate the same amount of carbon emissions as global airlines. You'll see an article from theconversation.com there. So here are some NLP leaders to follow that I think are all really brilliant people, some of whom I know personally very well, and others are more associates. So Dr. Emily Bender, Rachel Thomas, Dr. Catherine Breslin, Kathy Pearl, Dr. Leila El-Azri, and Christine McLeavy-Payne. So these are all world-class NLP leaders that I recommend you follow on Twitter and try and connect with on LinkedIn and connect in some way. They're all incredibly approachable and friendly. In particular, I had my best connections are with Dr. Breslin, Kathy Pearl, and Christian Payne. I can do direct introductions to those people as appropriate through the mechanisms set up in this program. The others I know on Twitter and such like, but these are great mentors to connect with that can augment over time and such like. They haven't signed up to be mentors, but you see their leadership in the Twitter community, and just even following them there can be a great thing to do. So that's the end of my conversation. So I have taken a bit more time, but I hopefully helped to answer the future question a wee bit, Elena, but I'm open to have further questions, and I'll be sticking around for the rest of the session.
Amazing. Thank you so much, Julian. That was fantastic. So I can see we've got a question from Andrea. Andrea, do you want to unmute yourself and ask the question?
Yeah, sure. I just wonder if in the future it's possible to detect human brain and to know, like for example, in the school, if they learn what they have for that day or not.
Right, so let me play back the question as I understand it. Detecting like what people have learnt or what people know by looking at their brain. Is that the question? Is that a good way of phrasing it, or is there something else?
It's that way.
Ah, great, okay. Yeah, so it's a brilliant question. Let me think about it for a moment, because I've got lots of different ways of responding to it, because it really is a profound question. So let's imagine you're in a class and you want to, for some reason, you want to know what people's knowledge has been, what have they picked up that day, and maybe it's for altruistic reasons. Maybe you want to do it because you want to identify areas that you can help them with, so you can help them with areas they can pick up, or maybe it's from a more slightly nefarious point of view, where you might want to punish them for not having paid attention, right? So there's lots of ways that could be used ethically. I'm putting an ethical framework on this. There's good and bad ways that technology can always be used. So thinking of that, the simple answer is that nothing right now can pick out what you know in your brain. That's the simple answer. Will it happen in future? It's science fiction right now. It's unclear. It's unknown what will happen and when that can be. That said, I'll tell you about specific things that are happening. In that world of I don't know what they call them, neurophysiology, neurokinetics, let's not call it any of those things. There are a bunch of pieces of research around this. The most, to me, worrisome prototype of this is there are some schools in China where they are attaching probes to the head of the kids, and the detection is simply an attention detection. So they're saying, is this child paying attention or not? And basically, if the child is not paying attention, then they get notified somehow. Either they do or the teacher does. I'm not sure what that is. And that could clearly be done, abused. It could be, if you don't understand or appreciate that young kids have an attention focus duration of 10 to 15 minutes, if you really force them to stay longer, that could be quite harmful. So that's one area where it's actually being applied right now. And in general, your question brings up a really good kind of excuse to explain a wee bit about the general way in which machine learning can work. So when you're looking at patterns, which is what machine learning is all about, it's actually a really good idea to just start with something really, really simple. it's really good to start with a simple yes, no. So if you want to detect a space, like for instance, I've been working on a project where I'm trying to detect whether some news is good news about climate change or bad news about climate change. Now, I could have started off saying, I want to categorize this climate change into political or fake news, or it could be, different parts of the world. I could have come up with all sorts of ways that I could have, lots of little bins that I could construct to represent this news. But one of the things you want to do when you're trying to create a machine learning system is you want many examples as possible. And one way to do that is by having as few bins to put them in. So if you have 10,000 examples and you've only got it's a cat or a dog, you've only got 2 bins, right? And that's very simple. Now you have 5,000 samples roughly of each. But if you say, I want a system that can detect animals, well, now you've probably got thousands of bins. And if you've only got 10,000 samples, then you're only going to have a couple of samples across them. So the same reason, there's in early stages of detecting brain activity, they're doing simple things like, are they paying attention or not? So they're looking at just really quite distinct patterns of behavior. Again, they're not necessarily even correct. Even though they made it simple, they may not be correct. And so as a result, what they're going to do, for good or bad, again, technology can be used and abused, is that they'll start learning in the real world, in the classrooms, about what is not correct prediction of behavior. So the kid may be doing something else and they go, well, I wasn't paying attention. And the teacher says, oh, I'm sorry. And they might press a button saying that was incorrectly categorized. So they start off with a very simple system that tries to do something very simple, what's called binary classification, so one or the other. And as you get more and more data and learning about that, you can start expanding the classes, the different bins or categories you're building up, so that you can start learning more and more. And so these prediction systems can start saying, well, you can start asking questions like, when they answered this question, were they lying or not? I mean, that is incredibly difficult to know because there's so many things that contribute to that. But there might be, again, it's an area of research, there might be activity in the brain that is closely connected to making things up, which is lying, versus telling the truth. And it turns out actually that with the synthesis parts of the brain, the creative parts of the brain kick in place, then that is actually a pretty good signal for determining whether they're lying. And that is actually much more useful signal than, say, the lie detectors, where they're detecting conductance on the skin, because that's just indicating stress, which could be anything. So it's quite easy to see that there'll be lie detectors that will start saying, get some training data where you say to someone, think of a purple flower, or think of a blue elephant, and just get them to think creatively and register the brain activity. And you do that a couple of million times, and after a while you might start getting some things saying, well, these parts of the brain consistently light up. But you want to get neurologists in there to identify, well, that's the real signal you want to pay attention to. And so it's a long-winded way of explaining your question, because you could then start saying, like, in terms of what you learned, you could ask questions rather than asking quizzes to say, what is 3 + 5? Okay, well, you haven't been doing addition today, or what is pi to 6 digits or something. You could, in theory, relax that, and you had a system, whether they're lying or not, saying, did you understand the sieve of Eratosthenes? And if you say yes, but you're making it up, then it may be the brain is like lighting up the creative area. And then you're saying, well, then you're being too creative in your answer, and the answer was a recall and it's a fact, so you're lying. So in terms of retention, equally, again, you can use this for positive things, saying, great, well, it does look like maybe there's an area that you could review, because you can't necessarily pick up what's going on, or you can't, you're making stuff up instead of trying to create something you remembered. So when it comes to recall versus creativity, that's almost certainly going to be an area that's going to develop. But to recap, I think the answer is it's a great aspiration, but it's almost certainly going to be broken down into simpler problems for some time and then built up, so that the idea of being able to recall specific facts. I happen to know a memory expert, and it's incredibly difficult, because when we recall things, our brain works such that we pull something out of memory, it's actually erased, and then we rewrite it again. And so the process of memory recall is actually synthetic as well. It's actually producing new memories, which is why we can create fake memories quite easily. So it's actually a really hard problem to solve, and definitely this the area of science fiction.
Amazing. Does anyone else have any questions at all? If you do, please post them in the chat room or unmute yourself and ask that question. From me, before we end, I just wanted to ask you, Julian, so we have a lot of young people who are just exploring AI technologies for the first time. If they were to attempt NLP, what should they be mindful of? Because ethics is something that's really important to us. And I want them to consider some of the, some of the ethical implications, what might go wrong. What should they be mindful of when they're developing NLP? Can you give us some examples of where technology really went badly?
Yeah, I've got some slides on this. So there's a great question. There's actually extracts from an entire day's workshop on this. So I'm going to dig this up some around bias. So so that's names, places, and things. Let's see, just sentiment, just going to dig its emotions. So NLP, one of the things is that there's a woman called Dr. Lisa Feldman Barrett, and she's written a great book called How Emotions Are Made. And she is, she's basically really convinced me that it's really basically impossible to detect someone's emotion from how they are in general. So you might be able to do it in a very, very specific context, but there's a lot of technologies out there and patents being established for technologies that really, they have questionable scientific foundations, I'll put it that way. So she's got a great video where she talks at Google about, can AI detect emotions? And the answer is probably not. And so I like this quote, which is that there is no such thing as an emotional fingerprint. And the example she gave was this. So what's the emotion of this character? And so there's lots of ways you can interpret it, but often people think that they're angry, but it's actually triumphal, so that they're actually happy. This goes on and on. But I've got some examples here of biases. Let's see if I got them here. Maybe I don't, but let's see if
I'm really glad you brought up the emotion example, because interestingly enough, tomorrow we do have somebody who is developing emotion AI.
Matt, really?
Yeah, you might know Matt Saluza quite well. He's just given an interview in the forums. He's up against Meredith Whittaker, actually, which is not.
So which company is this? Was it Matt, did you say?
Yeah, Matt. It used to be Crowd Emotion, and it's now something else. Let me tell you what it is. He's coming tomorrow at 5 o'clock. So you're welcome to join us as well, Julian.
I would love to know what the previous company name was, because I spent a year on natural language processing and analysis, and created this big weighty report on this. This is an excerpt from the slides, actually.
Yeah, that's fascinating. It's called Crowd Emotion, and right now he's working on Element Human. So he's coming tomorrow because I kind of challenged him. I was going to ask him to come and do a talk. He did a talk a couple of years ago in our accelerator.
Yeah. Brilliant. Element Human now, so they've renamed themselves. Yeah, I didn't come across them. So it could be, I mean, the space is so vast. When I did my research, I was looking at long form sentiment analysis, and not, whereas there's an entire subsection of industry that's focusing on emotion detection of short phrases, like for commands, for like less than 15 seconds. But the work we were doing was on actually transcriptions for call centers, which was several minutes long. So we're actually excluded a whole bunch of companies that weren't even touching that space. So there's actually an entire industry I didn't even look at. So there might be part of that. But here are some slides I remember now. So there's two things that are really worth bringing up here. Sentiment is fascinating. So sentiment is whether it's positive or negative. And we evaluated a whole bunch of systems here. So we got, 1, 2, 3, Aliens up in Ireland, and Lexalytics is, I can't remember where they are, but there's some open source ones here, and some big names as well. So the headline I want you to take away with this is that, so sentiment, there's bias with first names. So what I'm saying is that if you had you're saying, what is the sentiment of this expression? And they said, oh, Mary said it was fine. This is hypothetical, but the word Mary, if you substitute it for something like Alonso or Shaquille, there is actually bias associated with individual names. So you might find that Mary, Alonso, and Shaquille have, even if it's the same phrase, like Shaquille took it, Mary took it, Alonso took it, you might find, depending on the system, again, we did a whole lot of these, that there's actually different sentiment because those names are associated with lots of negative sentiment conversations on the web. So this is really scary stuff, right? So it's really good to check this fundamental, which is like, how do you deal with name bias? That's the first question I always want to check, which is extraordinary. You can see here that we had male and female bias. So we had negative bias with Google female names. So that is that there was, so you get negative bias on female names with Google, and everything else had, this was normalized, so one was good and one, I can't remember. So negative, less was negative, and positive was positive sentiment for names. So 1.0 normalized, meaning deep effects had the most positive sentiment bias. So deep effects had huge amount of positive bias. So Mary did it, would be like really positive, and probably Alonso and probably Shaquille as well. Whereas if it was like Maria, there's a chance, looking at this graph, that Google would have actually put a slightly negative, there would have been a negative bias because of that name. And that is jaw-dropping. When I saw that, I thought, oh my, it's just an area I doesn't really understand. Ethnicity too. There's another area. So ethnicity is where you have names and words that are in different languages. And so there is bias there too. And so it's clear that Google has done a good job with this, Amazon's done a good job with this. But when it comes to like understanding sentiment, the reason why this is important is, and why it's different to working with normal data sets, is that you often get a prepackaged model. You get a prepackaged data set. Well, not a data set, it's actually a calculation or a repository of numbers that represent that data set in a way that can be then used for a mathematical calculation. It's called the model. So that data, there's a text, it's a data file, it's called a model, and that data file has all of this built into it. So when you're starting in natural language processing, you almost never start from scratch. You're always starting from a pre-existing or pre-trained model, as they call it. So the question you've got to ask yourself is, for your context of use, you need to go back and say, well, where did you get the data from? So a good example, a hilarious example of this actually was, I was evaluating voice systems as well as text systems. And I tried one system where I had this transcription, a conversation with in a call center. And it came up really negative. It was a conversation with a woman in North England. So I think it was Mancunian accent, quite a strong accent. And to an untrained English ear, the Mancunian accent can sometimes come across as a bit aggressive, but because their inflections are just different. And sure enough, this system predicted that with 95% confidence, this conversation was aggressive and angry. And yet, when you listen to it, it was an entirely professional conversation with no anger at all. And so I asked them, I said, so tell me, this is the question you need to be asking. Where did you get your data from to train the system and its sentiment? And they said, from some 30-something professionals in Surrey and some Germans. I was like, okay, so that's useless. I didn't say that to them, obviously. But that question of where do you get your data from and what's that mix, you need to understand that, because that has to align with your context of use. If all you're going to be doing is running a system determining, the sentiment of 30-something males in Surrey, then you're set. But if you don't know, then you have to flag that as a risk, saying we don't know what the profile is of this data. We don't know where it came from, or where there's been intentional or unintentional bias. And so that's the foundational question when you ever start off with these systems. So if you have an API, a programmatic API, like all of these are APIs, they're pieces of code. You say, here's some text, give me the response. Here's the text, give me the response. you didn't give it any examples initially. It's just using whatever they had. You need to know what do they have. Sometimes they don't tell you, and that's a risk. So you have to go, well, I don't know. So how do you protect yourself against that? You come up with lots of controversial examples. This is called adversarial testing. And so you want to test like failure modes. You want to be really creative with your NLP if you're looking at sentiment or you're looking at other things, and go, well, what will happen if you put, these words, these swear words in this language with these, these biases, and that will be outrageous, and see what it comes up with. And that was a way of mitigating that. And if it doesn't come up, if it doesn't work, well, then there are ways around that depending on the system. I can dig into that more about how that can be worked in a follow-up. It's kind of more involved, but the headline is it's called fine-tuning, as I mentioned before. So some of these systems can be fine-tuned with more examples, and that can mitigate some of that bias. But if it's just an API that you can call and you can't change the underlying model that the API uses, the underlying system, then that's it may not work for you. You may find that you're introducing yourself to ethical and legal risk by using that system for your specific use case.
Okay, fantastic. So Julian, I will have to cut you off there because we're 5 minutes past 6, and I know we have a couple of more sessions running and meet and greet with the mentors. But that was a fantastic presentation, and we're so grateful you have, demystified so many incredible concepts. And I hope that was helpful. Was it helpful? So participants, can you give me some sentiment there, please, whether you enjoyed it or not so much? Okay, fantastic.